Greetings and welcome to the SQL Channel, a series of video trainings on the SQL language. My name is Stephen Feuerstein, and I'm a SQL developer just like you. This lesson is the latest in my rather extensive series on programming with collections, Oracle's array-like structures. The topic of this lesson is working with multi-level or nested collections, and I must warn you that it's among the most complicated features that I've ever run across in SQL. So I'll work on making it as simple and accessible as possible for you. Some quick reminders. If you haven't already done so, download the code and PowerPoint documents supporting this and other lessons from toadworld.com/sf, my initials, otherwise known as SQL Obsession. Let's take a look. At SQL Obsession, you have lots of SQL resources at your fingertips. Click on the demo zip link to download the zip file containing all the files that I will be using today. In addition, click on Trainings, Seminars, and Presentations to download PowerPoints that support what you'll be seeing. Make sure you're comfortable with the material covered in the previous lessons in this series. Now, in general, I just say that at the beginning of each of my lessons. It's an important thing to do, but for this lesson, you really need to have a good, solid grounding in your understanding of collections, especially using string indexes with associative arrays, which will be coming up a lot in the presentation. So make sure you know about collections, you know about working with collections, you're comfortable with them, and then tackle this one. So multi-level, aka nested collections. What are they? How do they work? How can you best put them to use in your application code? Well, first of all, a multi-level collection type is a type of array structure of collection whose element, that is the value that sits inside each of its different rows, is directly or indirectly another collection. So I might have a collection of collections, I might have a collection of records, each record contains a collection, and so on. Multi-level collections can be of any type, nested table, V-arrays, or associative arrays, and there are lots of different ways to utilize multi-level collections. Generally speaking, what you'll be doing is modeling normalized data structures in SQL collections, essentially taking those different tables you have defined relationally and mimicking them in all their glory and all their complexity with multi-level collections. You can also emulate multi-dimensional arrays, though SQL is probably not the best place to do complex multi-dimensional analysis. The syntax for working with multi-level collections can be really hard to parse in your head. Oracle obviously has gotten its handle around it. It can parse it and run your code. But it's going to take a while for you working with these complex structures to really understand how to utilize them and how to model your application data inside these collections. So let's take a look at a rather simple example, just introducing the basic concepts, the basic syntax. So what I'm going to be doing is working with object types, actually. So these are the object model within Oracle. There's something like classes and object-oriented languages. I'm going to create a vet visit. It's an object. And the vet visit has two attributes, a visit date and a reason for the visit. Just like you would create a table with two columns, here's an object type with two attributes. And then I'll create a table of object types. So this is a nested table of object types. So I have multiple visits to the vet. And then I'm going to create a pet object type. And a pet has several attributes. It has the tag number, so we can keep track of our pets, the name of the pet, what type of pet it is, the breed, and the pet care. What's the history of visits to the vet? So this object contains within it a list of visits to the vet. The visits to the vet is a list or a table of objects, the individual object information, visit information. Okay, great. Then I'm going to actually create a collection of pets. I have multiple pets. I need to keep track of all their information. So a bunch of pets is an associative array declared inside my SQL block. Everything prior to this have been schema level objects. My object type is defined in the SQL layer. My nested table of object types is defined in the schema level, and as is my other object type. But my associative array is declared inside my SQL block. So I've got multiple pets. Each pet is of this type. Each pet has within it a collection. So this is a multi-level collection object. Let's take a look at populating my pets number 1. So my pets number 1 is, let's see, that's the first element of this collection, which means it has to be of this type pet. So I initialize that pet object type. I assign values for the different attributes. The tag number is 100. The name of the pet is Mercury. The type of the pet, the breed, is African gray parrot. And then I need to add a list of visits to the vet. So I call my constructor function for the vet visits list, which is a nested table of object types. Within my list, I declare or initialize and construct multiple visits to the vet. On the 1st of January, we got her wings clipped. On the 1st of April, we checked her cholesterol. Yes, it's true, you do these things for these big, expensive, smart birds. So this whole thing constructs a single element, a single object, that goes into my collection at the first location in my list. And it has within it another list composed of 2 different visits to the vet. Now, it's not always this complicated to construct, simply assign a value to a multi-level collection. It's this complex because I have these object types, but I thought it'd be a nice way to introduce this functionality to you if you haven't run into it before. So multiple visits to the vet goes into my vet visit lists. That whole thing goes into my pet. That pet goes into the first element in my list of pets. Let's take a look at accessing the elements of this complex structure. If I want to see the name of my first pet, I go to my collection, my pets, the first index value, dot name. Just like record.field, I do object type dot name. Let's say that I want to see the reason for the second visit for this to the vet for this animal. My pets 1 takes me to the first pet. Pet care is the name of the list of visits to the vet. That's a collection. So this whole thing is a collection. I go to the second location in that collection. This whole thing is an object type. It has as one of its elements or attributes the reason, and there's the reason. So one level dot second level dot attribute or field. If I just want to get the number of pets, that's just using the same old method. If I want to get the first visit to the vet, I would go to my pets 1, that's an object type instance, go to its list of visits to the vet, and ask for the first one. And if I want to, I can also make things a little bit clearer in my code. Instead of having a lot of hard-coded values, I could also hide the details. I could declare an object type instance as a variable, the first pet, and the first pet is my pets, and then find the first one. So this returns the first in the list. The last visit is, let's see, the first pet dot pet care. So this is my pet, the African gray parrot. This is the list of visits to the vet. Go to the last visit to the vet. Notice I have to repeat L first pet dot pet care dot last. And then I can see the reason for that last visit. So this gets me to the same place as this, but with less hard coding and demonstrating how you can create these intermediate objects or variables in your code to perhaps make it a little bit clearer as to what you're doing. Let's run the code. We'll ignore that. And there we go. So the name of my pet is Mercury. The reason for the second visit was to check her cholesterol. The number of elements in my list of pets is 1. The first index value is 1. And again, I asked for the reason for the last visit, check cholesterol. So it all works, and I bet you're looking at this code and thinking to yourself, this is really complicated. So here's my suggestion. You could stop right now, or certainly when I'm done with the whole lesson, go over this piece of code line by line. Make sure you understand how each element is defined. Again, if you're new to object types, that'll introduce another level of complexity, but there's nothing complicated here. It's just like creating a table with a bunch of columns, except it's an object type with a bunch of attributes. So make sure you understand the steps of the construction, and then make sure you can parse each one of these statements in your head and understand how they get the answer that they do. Then I would say you should continue on with this lesson, because it only gets more complicated from here. Okay, so that's an introduction to some of the syntax, the complexities, the fact that if you have a two-level nested collection, you're likely to have two dots. If you have a four-level nested collection, you'll have four. X.Y.Z.Q. It can be very complicated, and you'll be seeing some examples like that. Let's take a look at another example, because definitely the best way to absorb what you can do with multi-level collections, how they work and what they look like, is simply to run through a bunch of examples. Now, back in my lesson on working with string index collections, I talked about the string tracker package, and basically I needed to keep track of the names of variables that I was using as I generated some code, because I didn't want to generate a declaration of the same name variable twice. So I built a package that would allow me to keep track of that information using a string index collection, allowing me to keep my code really, really simple. And that worked fine for a single list, and I'll show it to you in just a moment. But what if I needed to keep track of multiple lists and even lists within lists? Then that single list structure doesn't work very well, and it's a perfect opportunity to bring in multi-level collections. So what I'm going to do is extend that first version of my package to support multiple lists by using a string indexed multi-level collection, essentially a list of lists, literally in my code. Now, I don't need multi-level collections to do this. I could do it the hard way, and in fact, in the old days when Oracle didn't support nested collections, which was first introduced in 9.2, I did the things the hard way, just like this. In other words, I took one big collection, one big associative array, which can have up to about 4.3 billion elements in it, lots and lots of index values to choose from. And I would segment that one big collection. I would say, well, all the elements, all the index values between 1 and 10,000, that goes to list 1. List 2 is 10,001 to 20,000. List 3, whoops, sorry about that. List 3 is 20,001 to 30,000. I knew that my list would never get to be this big, so allocating 10,000 for each one would be fine. And so I could use one collection, I could assign different parts of my collection to different lists, and then I had to write fairly complicated code to manage the offsets. Well, if it's list ABC, that's from 20,001 to 3,000. If it's list 1, 2, 3, that's from 10,001 to 20,000. And the code was very complicated. I got the job done, but it was a hard way to use these data structures. And in fact, in general, that's what you want to be keeping your eye out for, and you'll see demonstrated in this lesson multiple times. If you find that the code is getting too complicated, if you're saying to yourself, it can't be this hard, there's got to be an easier way, then there usually is. And multi-level collections can be a really nice way to simplify your code, even if the resulting data structures that you define are more complex. So I don't want to do this. I don't want to build a lot of code to segment out a single list. I want to build the intelligence in the data structures themselves. Let's take a look. So first of all, string tracker 1. Just to refresh your memory, with string tracker 1, I want to mark a string as being used, and I want to be able to find out, is a string already in use? And what I did was create a list of, well, it doesn't matter, indexed by variable name. And what I did here was use subtypes and constants to hide the actual data types to make my code more readable. But the bottom line is, I'm going to index by the variable name, and the contents of the collection really doesn't matter at all. With my string index collection, all I had to do is the following. To mark a string as being used, take that string name, use it as the index value in my collection. The value that I assign to it doesn't really matter. It could be null, true, false, date, string, whatever. Doesn't matter, because I never look at it. To determine if my string is in use, I simply ask, does this variable name, is this value you already used as an index value in this collection? So the exists method immediately tells me whether or not that string is in use. So this is an example of how I could use string indexing to greatly simplify my code. And again, if this is new to you, I urge you to stop watching this lesson now. Go back and watch the using string index collections, and you'll be able to then take much more advantage of this lesson, understand it much more easily. But that's my first version. And for a single list of strings, just keeping track of the list of strings I've used, it works really, really nicely. It's a very simple and elegant solution. As you can see, there's almost no code here. all the work is being done by Oracle and the collection definition. The problem is that's not good enough. I need to maintain lists within lists, multiple lists, all sorts of different stuff. So what I need to do is extend the definition of this package and what it does. Let's take a look at String Tracker version 2. Now in the original version of my package, all I did was say mark the string as being used in the list. Is the string in use in the list? But if I have multiple lists, lists within lists, then things get more complicated. So I'm going to go back to my package specification. And I'm going to extend my API. I'm going to support the idea of creating a list, pass in the name of the list, the description of the list, whether or not you want to override the existing contents of the list, and that will create a list for me. Then I want to mark a string as being used in a particular list. I want to see if a string is in use in a particular list. So I have to add the list name to my parameters. So the package specification already exhibits the extension of functionality of this utility. Let's take a look at the package body. I'm sorry, before I go on, notice also that I create a number of subtypes. Subtypes are a great way to make my code more readable, to hide the underlying data structure. For more information about subtypes, watch my Stop or Say Goodbye to Hard Coding lesson series. So I declare a subtype called maxVarchar2, the maximum size allowed in PL SQL. I declare a list name type. I declare a value string type based on the previous subtype. And you can see them coming into play right here. Pass in my list name, it's of type listName T. Pass in my value string, it's of type value string T. So they self-document the value coming in, which is already pretty well documented by the name of the parameter. It's less important here than in the package body. Let's take a look at the package body. Now all the code from line 15 to line 29 is nothing more than defining my multi-level collection structure. So as you can see, it's a fair amount of code, and there are even more complex examples that you will see. Let's take it step by step. In fact, I'm going to start from the bottom and work my way back up. I need to maintain a list of lists. For a given list name, I have elements in that list, and I can have multiple lists with different names. So I need something called, or of type, list of lists. What is a list of lists? A list of lists is a table of or collection of records indexed by the list name. So each list name is unique. I will use that as the index scheme into the list of values. That makes sense, right? Each element in this list is a record. So let's take a look at that. Each record for a list consists of a description field, which I pass in, and a list of values. Notice the name is not an attribute of my record. It's not one of the fields because it's the index value. It would be redundant to keep it here. So my list consists of the description, which is the maximum size possible, and a list of values. My list of values is another collection. This is a multi-level collection, clearly. And that list of values is the list of used elements. I want to keep track of the names that I've used. It's a table of, who cares? It doesn't matter. Happens to be a Boolean, but it really doesn't matter because I never look at the value. And it's indexed by the value string. So there's an example of a collection of records, which itself contains another collection, which itself is indexed by a string. So I have a two-level nested string indexed collection. And notice again that I've used my subtypes throughout. If I didn't, things would look a little bit different. So hopefully you can understand what I just said to you. Again, if it doesn't make sense, stop the video now and walk through those lines of code and ask yourself if you understand the construction of this type. Assuming you do, let's go back and take out these subtypes just to give you a sense of what happens when you don't use them. So I'm going to change my index by to my actual types. There's my 32767. Here's my Boolean. So this is what the code would look like without my subtypes. It's a table of Booleans indexed by varchar2. Wow, what does that do for me? If I write code like this without using subtypes, I need to put in a comment saying indexing by the variable name, indexing by the list name. I need to document, I need to add comments just to make people understand the code that I wrote. Well, that doesn't make any sense. Don't write comments if you can use the code itself to explain what's going on. Let's go back to the original version. Now it tells its own story. It's a table of who cares, meaning it doesn't matter what value it is, indexed by the value string. It's a table of list records, indexed by the list name. So please make sure when you work with these complex structures to always use subtypes, constants to hide the values and hide the hard-coded types, self-documenting what you're doing. Okay, so I declare my variable list of lists based on this complex structure. Let's use it. Let's go to create list. Now, the example I'm showing you has a little bit too much of features, bells and whistles, for example. Do I want to override it and so on? Let's just simplify things a bit. We're not going to worry about the overriding process right now. We're just going to look at the creation process for the list. So, we get rid of that, it doesn't matter. I'm going to declare a local record of the type that's defined as one of my lists, table of list records. And the list record, in case you forget, has description and list of values. So I'm going to assign the description in to my description field of my list. I'll assign my list to the location in my array, my list of lists, defined by my list name. So the list name is my index value. I don't add sequentially to the list. I put it in directly for that list name. So that's an example of populating a list of lists. Now you don't see the list of values yet because I'm just creating the list. So right now it doesn't even look like a multi-level collection. You don't know, for example, from looking at this code, that the list record has within it another collection, but it does, and we'll see that in a moment. The main thing, though, is to understand how this assignment creates a new list. And in fact, I don't even need this intermediate list. I can simply do the following. So what I'm saying here is assign this description to the description field of my list of lists for this particular list. And in this one assignment, it'll automatically create the record, if it didn't already exist, with that location in the list, and then assign the value to the description. So you don't need these intermediate steps. It can just make things a bit easier on the eye when you have it. The record is assigned the description. The record is assigned to my collection. Okay, so that creates a list. Let's take a look at how I mark a list or a string is being used in a list. Here's the single assignment. I go to my list of lists. I go to that named list. This whole thing is itself a record of type list_rt. I go to its list of values, so record dot list of values. This itself is another collection, a collection of booleans. I go to the location in my list of booleans indicated by the value string. It's a string index collection. And I assign to it the value of doesn't matter. So again, I'm self-documenting that the contents of my collection, in this case, don't matter at all. What matters is the fact that I'm using up this location in my list, which has this name. So that single assignment takes care of everything for me. It marks this string as being used in this list. Now, when you first start working with these structures, and especially when you're working with somebody else's data structures that you didn't design yourself, parsing this kind of statement can be quite challenging. So again, if you want to, you could fully expand it. So what I'm going to do now is show you what it would look like, not as a single assignment, but as a series of assignments. So, get the record that's defined by that list name. There it is. There's my record. Get the list of values for that record and assign the value to that list. So this is a local variable that contains the current list of values for that list. I'm going to add doesn't matter to that list of values, but basically what I'm doing is assigning the location in the string. So I've added a new location to my list of values. And then I assign that list of values to the list of values field of my record, which is identified by that list name. So if you want, you can go through all these steps, but really what you should do instead is make sure that you're comfortable with this logic that you use named elements to make it easy to understand what they are, or easier to understand what they are, and then work with that single assignment. Finally, is a string in use? Pass in the name, pass in the string. And again, I'm going to be using the exists method to ask, does an element exist at that location? So first, does the list exist? Because if the list itself has not been defined, clearly no string is in use in that list. So if the list exists, then go to that list name in the list. This whole thing is, once again, a record. That record has as one of its field the list of values. This is a collection. And the question is, have I already used this string in this list of values? So I ask